Okay, so this is a video on the NF-kappa B pathway. So here's a picture of the pathway. We have NF-kappa B, which is composed of P50 and P65 subunits. It's bound to I-kappa B, which is the inhibitor of kappa B, to ensure that NF-kappa B is activated by the appropriate stimuli. The interaction prevents NLS of NF-kappa B from interacting with the important. When NF-kappa B needs to be activated, the I-kappa B is going to be phosphorylated. So we have a phosphate coming in here. That's going to add a negative charge, and it's going to cause the I-kappa B to be rapidly degraded. That phosphate is going to add a negative charge, which is going to change the shape and cause the I-kappa B to be ubiquinated or degraded. So that I-kappa B is going to leave, just like it is here, because of that phosphorylation. And this is going to uncover the NF-kappa B's NLS. You can see it in that third picture right there. You have an exposed NLS region. And that's going to allow it to interact with an important, which is in the pink, and it's going to be able to enter the nucleus where it interacts with a coactivator, and it can transcribe or do transcription of its target genes. So we already covered the NF-kappa B pathway in terms of import, but what happens when we want to terminate the transcriptional response? So we have to keep in mind that I-kappa B contains both an NLS and an NES, and it shuttles between the cytoplasm and the nucleus. So it has that NLS, that nuclear localization signal, as well as a nuclear export signal. So essentially, the newly synthesized I-kappa B is going to enter the nucleus from the cytoplasm, where it binds. As we see in a minute, it's going to bind to the active site of the NF-kappa B, which remember is composed of P50 and P65. So when that I-kappa B binds, what we're going to have is the promotion of nuclear export. So as we see here, the I-kappa B is binding to that NF-kappa B region. So the interaction between that I-kappa B binding to the NF-kappa B is going to hide the NLS, the nuclear localization signal of NF-kappa B. And the interaction is also going to hide the NLS in I-kappa B. So then we are going to have an exportin that's going to come and bind to that entire complex. And because both of the NLSs are hidden, both on the NF-kappa B and the I-kappa B, the complex is going to stay in the cytoplasm, preventing any further NF-kappa B transcriptional activation. So as we see in a minute, we're going to see that entire complex move from the cytoplasm, or from the nucleus into the cytoplasm, because we don't want any more transcriptional activation to occur. So we have the P65 moving, and then we're going to have the rest of the complex move into the cytoplasm as well.